Welcome to the course of IoT Lab, Internet of Things Lab. In today's week 1 session, we are going to learn what are the different types of sensors and actuators. And we are also going to see what is the architecture of Internet of Things looks like and how the each and every layer performs. And not only that, we are also going to see the gateway of how an IoT device or an IoT network works. Now, coming to the initial part of sensors and actuators, initially we are going to see what are the different types of sensors, actually what is a sensor, and actually how actuators are helping these IoT devices. We are going to see each and every one. To keep it simple, a sensor is a device used for the conversion of physical events or characteristics into an electrical signal. For example, let's take a thermometer. So suppose we get a fever, okay? So this particular thermometer is used to capture the physical events of the body temperature, and it will be converted it into an electrical signal, and further due to some processing, that particular temperature will be converted into degrees Celsius or Fahrenheit, and it will be displayed on a small display. Okay, so this is a best and basic example of how a sensor works. Not only this, it can be monitoring any health of a plant, or it can be monitoring oxygen levels, different types of gases in the atmosphere, or it can be anything. Any sensor will be working on the same principle. It converts the physical events into the electrical signals, and these electrical signals will be processed further, and in order to have some output in the form of a display or any kind of mechanism. Now, coming to some types of sensors, we have temperature sensor, as I have taken the example of temperature, monitoring the temperature. We have light sensors or light intensity sensors. It is for detecting the intensity of light, as we know, like LDRs, light dependent resistor sensors, or street light and day and night detection of system. And not only that, we have pressure sensors in order to measure the pressure of gases or liquids, and we also have motion sensors to recognize the motion in an established regions. These are the basic sensors which we are seeing right now, but there are multiples and many different types of sensors which will be almost helping the IoT device or an application based on its usage. Now, coming to the advantages of sensor, let's see some of the advantages of sensor. So it offers timely and accurate information, as this is a critical requirement by high release frequency. Not only that, it supports awesome automation and management of systems. And the third advantage, what we can consider it is, it improves the safeties by maintaining the check on important parameters. Then along with the advantages, we also have disadvantages of sensors, like sometimes it can be costly. Suppose if you consider an NPK sensor, it will be, you can get it for a little bit costly wise, like 5,000 or 7,000, or sometimes you get it for a 10,000. If you have an high precision infrared detectors or infrared sensors, we get it for an costly amounts only. Okay, so another disadvantage is like it can sometimes need some adjustments and can also probably require maintenance in the long run. So interference from the environment is very much easy in this process. Next, coming to the actuators. So actuator is a device that converts the electrical signals into the physical events. Okay, so the actuator, almost we can say it satisfies the output parameters or the output devices of a particular IoT device. So it takes an input from the systems and gives the input to the gives the output to the environment. For examples, we can consider motors, heaters, or some of the commonly used actuators. All these things which will be helping us to produce the output, or which acts as an output, will be considered as an actuator. Now let's take some types of actuators. We have linear actuators, rotary actuators, hydraulic actuators, pneumatic actuators. All these actuators are produces different types of outputs in different variations. Suppose if you take the example of linear actuators, it utilize a linear motion to convert the energy into a form of a kinetic or pendulum energy. So if you take the rotary actuators, this will affect the creation of a rotational motion. Hydraulic actuator, it does fluid power and gives the motion. So pneumatic actuators, it functions with the use of the compressed air. Okay. Now coming to the advantages of actuators. So these actuators will be assist of providing a fine level of control of mechanical installations. And the next advantage is they also enable automation and therefore minimize the need for intervention of the human participants. Now, next, the third advantage of the actuator can be like, it can be, these actuators are available in different types of ranges and variations and are suitable in multiple operations ranging from everyday use to high-end like industrial uses. Now, you also have disadvantages for these actuators. So, as many of the actuators, while performing, they consume very much high power, which where the energy consumption is very, very high. Okay. And the second disadvantage can be, it can be sometimes the actuators can be large and also costly to both install and maintain. And the third disadvantage is like the after few years of usage, these actuators can be go into an wear and tear. So simply we can say that sensors are like input mechanism or the input devices or the input modules for the IoT devices. Actuator can act as an output devices for the IoT machines. Okay. So these are the few brief about the sensors and actuators. So if you take a simple difference between a sensor and actuator, coming to the sensor, it converts physical characteristics into electrical signals, whereas actuators, it converts electrical signals into physical characters like running of a motor or anything else. Coming to the sensor, it takes input from the environment, and actuator, it takes input from the output conditioning unit of the system. So coming to the sensor, it gives output to the input conditioning unit of the system, whereas the actuator, it gives output to the environment. Whereas coming to the sensor, sensor generated electrical signals, actuator generates heat or motion in form of some action. Okay. So coming to the sensor, it is placed at input port of the system and the actuator is placed at the output port of the system. Coming to the sensor, it is generally used to measure the physical quantity, and actuator is used to measure the continuous and discrete process parameters. For example, if you say a 360 rotating of the motor, or it can be a servo motor which can rotate 180 degrees, or it can be a stepper motor which rotates in the form of steps. So all these things can be considered under the actuator. So under the sensors, it gives information to the system about the environment, and the actuator, it accepts commands to perform a function. So it can be a controller or processor from which this actuator takes the input and performs the actions accordingly. Suppose if you take the example, photovoltaic cells which converts light energy into electrical energy. So let's say this particular photovoltaic cells is generally used in solar panels. So solar panel will be acting as a sensor which converts this light or the sunlight energy into the electrical energy. While coming to the actuator, the best example of the actuator is like stepper motor, which will be electrically driving that electrical energy drives that particular motor. Now, all these sensors and actuators are much more interface to this particular Internet of Things. Okay. So let's talk about simply what are these things. So things can be a combination of various electrical and electronic components. Wherever we give an input, it produces an output. Okay. Now coming to the Internet of Things, where this particular device is attached to the internet such that we can control or monitor that particular device. So you can attach some sensors to this particular IoT device, and you can attach some actuators to this IoT device, and you can control or monitor this particular IoT device wirelessly through internet. As these days the internet of things or the internet is growing faster and faster, internet has been connected to this particular electronic device to make it much more efficient and work wirelessly for a larger distances. Okay. Now, under this architecture of IoT, we have different types of layers. So this architecture of IoT is divided into 4 different layers. First one is the sensing layer. Second one is the network layer. Third one is the data processing layer. And the fourth one is the application layer. Now let's see the layers one by one. Okay. So coming to the sensing layer. So the sensing layer is the first layer of the IoT architecture, which is responsible for collecting the data from different sources. So this particular layer will be completely equipped with different types of sensors, like it can gather information about, it can be temperature, humidity, light, sound, or any kind of physical parameters. Now coming to the network layer. So this network layer of an IoT architecture is mainly responsible on providing communication and connectivity between the devices in the IoT system. So it can be like connecting an IoT using Wi-Fi, Bluetooth, Zigbee, 4G or 5G technologies, through which you can monitor or control the particular IoT device, or you can gather some information on your dashboard or screen or monitor through the internet. So this particular network layer will be helping in that particular aspect. Next thing covers the data processing layer. So the data processing layer of IoT architecture refers to hardware and software components that are responsible for collecting, analyzing, and interpreting data from IoT devices. So this particular processing layer will be majorly focusing on collecting, analyzing, and interpreting data, which can be taken as an input or considered as an output from that particular IoT device. And the next layer is like application layer. So this is the application layer where you can observe the output. It can be like you are observing the output through mobile apps or through web portals or some kind of user interfaces or anything. So somewhere you have installed that particular IoT device, which is attached to an different types of sensors, and it will have some controller or processor which will be connected over Wi-Fi, and that data you are observing in the real time through mobile apps, web portal, or any other user interfaces. This is where the last output is evolved through this particular application layer. So this application layer also includes the analytics like processing capabilities, uh, processing capabilities that allow data to be analyzed and transformed into meaningful insights. So it can include machine learning algorithms, data visualization tools, and other advanced analytical capabilities. So these are the block diagram where you can see the data flow, where 4 stages of IoT architecture is involved: application layer, data processing layer, network layer, sensing layer. So if you see the application layer, you have smart applications and management. Data processing layer, you have processing unit, data analytics, and decision unit. Network layer, we have internet gateway, internet network technology. Sensing layer, we have physical object sensor and actuation, where all the data will be gathered into that particular. Now coming to the advantages of IoT. So nowadays, each and every home appliances or IoT device is connected over internet. We're coming to the advantages of IoT. You can execute multiple tasks at a time like a computer. So we have one more advantage is all these devices are internet connectivity and are connected over internet, which can be viewed or monitored or controlled over wirelessly using internet. So and the third advantage is like it completely works on GUI, like graphical user interface mode through the HDMI port. You can also connect a monitor or screen through the HDMI port, and you can visually see the web application, web apps, or the whatever the data is gathered through the sensors. All those things can be monitored over a beautiful user interface. Now, the fourth advantage is like it is best suitable for server-based application. So it can be connected via SSH like secure shell, and to access the Raspberry Pi command line remotely, file sharing can be done via file transfer protocol, and you also have more reliable for software applications. Next, coming to the disadvantages of IoTs, the first disadvantage is like security concern. So there might be like hacking or data breaches sometimes, which can be one of the disadvantage of the IoT. And we also have like privacy issues like collection and usage of personal data. That can be one of the disadvantage. And we have some more disadvantages like we are completely depending on the technology, and once you are habited to that particular technology and if it suddenly fails, you will feel some lack of loneliness or dependent on that particular. So dependence of technology is also can be considered as one of the disadvantage. And you also have limited standardization and interoperability, and we also have the complexity. So as you keep on designing different types of designs or products, okay, the complexity also and maintenance requirements is also increased. Okay, high initial investment cost. Okay, so as you need to initialize that particular device, or if you want to design that particular product, the investment also sometimes will be very high. Okay, and as these particular devices need to run on some particular power, we have limited battery life for some devices. Okay, so these can be like limited regulation, legal framework of IoT. All these can be considered some of the disadvantages of the IoT. And coming to the modern applications of IoT, we have smart grids, energy saving, smart cities, smart homes or for home automation, healthcare, healthcare, earthquake detection, radiation detection and gas detections, smartphone detections, water flow monitoring, traffic monitoring, smart door lock protection system, robots and drones, integrating IoT technology for robots as well as drones, healthcare and hospitals, telemedicine applications, biochip transponders, heart monitoring imports. All this will be considering or comes under this IoT application. So